I'm Anthony with Dude We Can Build It, and today we're building a wraparound porch. I've always wanted to have a wraparound porch, but when I built my house, I couldn't afford to build all of it all at once. So I've been building it a section at a time. Once I got ready to start building the back porch, I didn't film this part, but I took my skid steer and I just scraped all the grass off of the area where we were going to be pouring concrete and building the porch. Once the prep work was complete, the first step is to set our 4" by 4" galvanized posts in the ground. When we built the front porch, I have some of the posts where they're starting to rust right where the metal touches the ground because the moisture content of the soil is apparently too high and is causing surface rust. So I wanted to go ahead and add an extra layer of protection for that metal before I stuck it in the ground. And I took the first 4 feet of our posts and I sprayed them with galvanized paint. And then we set those posts in the ground and filled it up with concrete to make sure it was nice and solid. Setting the posts is the most important part of this process because everything else is getting built onto it. The posts need to be in line with the ends of the house, and they also need to be perfectly straight in line with each other. So to get it in line with the house, we took a string line and we ran it alongside the house and brought it out to where it was touching both the front and the back of the same side of the house. So we have a nice straight line, and that allowed us to set up our first 2 posts perfectly in line with one side of the house. Then we went to the back side of the house and did the same thing. And then once we had our 4 corner posts set in place, we're able to simply run a string line down it and then set all of our posts in the middle and have them all be in a perfectly straight line based on that nice tight string that's going from the corners. Now we're gonna let the concrete sit overnight before we start doing anything else. We're back out here nice and early for day 2, and the goal for the day is to get the entire superstructure put up and have it ready to start putting sheet metal on tomorrow morning. So we start down on one end hanging our open Cs, and these open Cs are going to receive the purlins that are running in 20-foot sections down the length of the porch. This part of the project is pretty straightforward and simple, though it can be a little bit time consuming to get all of our measurements exactly correct. You don't really have any play when it comes to cutting things out of metal. Whereas like with wood, there's always a bow and it's easy to just kind of chip out a little bit or cut a little bit off. Metal is a little more precise and it's a lot straighter and a lot more uniform. And this kind of gets into a point that I wanted to talk about. When I decided to build a porch, I'd build porches in the past out of wood, but the problem with wood is that it's not really a lifetime product. It's something that requires a lot of maintenance and is also going to need to be replaced probably every 10 to 15 years. Now, when I'm building this Barndominium, the reason I decided to go with a metal shell for the Barndominium is because I really want something that will last a lifetime. And what I mean by that is at least a 50-year lifespan out of the material, but with just a little bit of maintenance, which metal is relatively low maintenance as long as you're keeping up with making sure that there's no rust happening and maybe doing spot touch-ups on paint. There's no reason that a building like this shouldn't last well beyond 100 years. Now that the superstructure is built, it's time to put the sheet metal on. We're using 26 gauge, which is a little bit thicker than your normal residential gauge. 26 is generally what you're going to see on commercial buildings, and it also has the larger 1¼ ribs instead of the smaller 3/4 inch ribs like the siding on the actual house has. So this thicker metal with the bigger ribs gives it a lot more strength. So if you're walking on it, but you're not standing on any of the purlins, it's still very rigid. And this is also something that allows us to have the 5-foot span in between supports. The sheet metal that I'm using is polar white on top, which matches the roof of the Barndominium. And the reason that I'm using polar white is because it reflects the most out of any other color of the sunlight back away from the house. So it's going to keep the porch and the house much cooler than say if I had done a black roof, which would absorb a lot more of the sun's heat. As we're installing these panels, the biggest thing that we have to make sure is that they are installed straight. That's why we took our time with the posts and building the superstructure to make sure that everything was as square as possible. The panels go on pretty quick. We make sure that the visible end of all these panels is straight and square. Now on the other side of the panel that's going up against the house, I'm actually bending the flat portion of these panels up, and that's going to be a backstop or a dam, if you will. So if there's rain coming down and there's wind pushing that water towards the house, there's a dam that water is going to hit and not be able to get to the other side. If that metal was flat, then that water could get pushed by the air and drip down underneath the porch. So it's very important to always bend up the end of that metal to make sure that the water can't run towards the house. I purchased all of the metal for the back and the end cap of the porch from a local company for $4,000. I spent a little bit more on the actual ticket because I purchased some extra purlins for another project. So if you do look at our documents, you'll see that there's a couple $100 extra, and that's why. I also spent $2,000 hiring some extra labor to come give me a hand building the porch, because this is not a one-person job. The next phase of this project is going to be burying both water and electric lines underneath the ground before I pour concrete. I have a lot of different projects that I'm planning on doing currently and in the future. So what you see me doing here is burying a conduit for electric that's going to an outdoor kitchen that's going to be under the next section of the porch, along with a hot and cold water line that's also traveling through a conduit. And then I have 2 1.25-inch water lines that I'm just stubbing out for now, but those are actually going to run all the way to the pond, and I'm going to have a closed loop cooling system where I'm going to put a radiator in the pond and then a radiator in my house near a ceiling fan with a high volume or low volume pump, I haven't decided yet, that's just going to circulate water through this closed circuit cooling loop. And essentially it's going to collect heat from inside the house and dissipate it in the pond. So the goal here is, say during a hurricane or something like that, I won't have to run my central air conditioning unit. All I'll need to run is a fan inside and a low volume pump to keep the circulation going in this closed loop system, which that should be doable with a battery pack and just a couple of solar panels. On the other side of the house, I also buried a drain line that's going to a sidewalk drain that's going to be for an outdoor shower to collect all that water and run it through the sewer system instead of having it run off into the yard. All of the material for burying the electrical conduit and the water lines cost $75. The next stage in this project is forming up for the concrete. So I'm starting out with 2x6s and 2x4s, and I'm making out the area where I want the concrete to be at. This part of the project is fairly simple and straightforward, and I did all of this by myself. I started by running a 2x4 from the corner of the house out past the first corner post. I set that in place with a couple of stakes, screwed it together, and then I did the same thing on the far side. After that, I ran a string line and I used that to straighten up a 2x6 board all the way down the front of it. And then I came back and put stakes in to level it and make sure that it was nice and straight. I just set a long 2x6 that's spliced in 16-foot sections, and I have 4 to 5 foot splices, and you can see how wavy the board is. And then I took stakes and I drove them in where the string line is at, and then I used those to pull and push the board to where it needed to go. As I'm doing this, you can see how the board gets straightened out, and then I also use the stakes to lift and attach the board where it needs to be and make sure that this entire run is not only straight but also level at the same time. Once I'm done with all of the perimeter boards, I'm going to take this 6mm underlayment or visqueen, and I'm going to roll it out over the entire area. And this is the moisture barrier, so that when it rains and the soil underneath gets saturated, that moisture is not going to be able to come up through the concrete and make the entire back porch saturated as well. I got a brand new stapler. I gotta take that out of the packaging. And it's a really cool one. Instead of one that has a trigger, it's a hammer type stapler. So I'm gonna cut around these posts to where the visqueen can be attached directly to the 2x4s or the 2x6s. And then I'm just going to staple it in so that the visqueen will stay in place. Now that the visqueen's in place, I'm going to use treated 1x4s as my expansion joints every 20 feet. It's very important to have expansion joints because if you don't, when concrete expands and contracts, it's going to find the weakest point and you're going to end up with a crack. So instead of it finding its own weakest point, I prefer it to be uniform. So I'm going to decide where the weak point is and I'm going to put a 1x4 there, and that 1x4, being that it's a fibrous material and it's also compressible, when that concrete expands, it can push on that 1x4 and the 1x4 will shrink a little bit and allow it to have enough give to where the concrete won't crack. I didn't purchase any lumber or materials to form up for the concrete. However, for the sake of transparency, I went ahead and priced out all the materials that I used from Home Depot and it all came out to $180. As we get ready to pour the concrete, we do need to make sure that our sidewalk drain for the shower is in the correct location, staked down, and nice and level with our expansion joints, which the expansion joint is going to mark where the top of the concrete is, because that actually is what they're gauging the slope from the house to the outside of the form. And there is slope from the house to the outside of the form. So if I ever got to wash off the porch, all the water will naturally run away from the house. We also moved the package unit air conditioner off of the work area and I taped up the ducts. That way we could pour concrete. And after this is set up for a couple of days, I'm going to reinstall the package unit on top of the concrete and hook it back into the ductwork. You might notice that there's no metal reinforcement in this concrete slab. That's because I prefer using fiber mesh reinforcement, which is just millions of small fibers that are embedded and mixed into the concrete. And what happens is concrete cracks. And when concrete starts to crack, it starts out as a microscopic crack. And the sooner that crack runs into a piece of reinforcement, the sooner that crack stops expanding. So if you have an 8-inch metal grid for reinforcement, that crack could potentially become 8 inches long before it runs into any reinforcements. That's a pretty good size crack. With the fiber reinforcement, that crack is only gonna grow possibly a centimeter or two before it runs into reinforcement and stops expanding. So for that reason, I much prefer the fiber mesh. It's also a lot easier to work with. And if you do end up using the metal reinforcement, it's not ever going to be installed perfectly, because the metal is supposed to be directly in the middle of your concrete slab. But when you start your pour, it's laying on the ground. And as you pour the concrete, you have to grab it and pull it up towards the center. So inevitably, it's not gonna be perfectly in the center. It may be on the lower quarter of it or the higher quarter of it and moving around like that. So it's not an ideal placement for that reinforcement anyway. So for those reasons, I prefer just doing the fiber instead. With this porch, there's nothing load bearing. The posts are going 3 feet into the ground, so all of the load bearing is already set in place. Like, we set the posts, we put the concrete on them, all that's load bearing. So the slab, which is a 6-inch thick slab, which is more than is necessary for just pedestrian traffic walking around, hanging out on. Generally, you would only do a 4-inch slab, but I went ahead and did a 6-inch slab because I want it to be more durable than it needs to be. I also upgraded to 3,000 PSI mix instead of the standard 2,500 pound mix, and I added the fiber reinforcement into the concrete mix. Now, each of these upgrades generally adds $8 per yard. The going from 2,500 to 3,000 PSI and the adding the fiber reinforcement adds about $16 per yard to the base cost, which right now is around $150 a yard. So I'm paying $166 per yard for my concrete because it has the reinforcement built in and it's a higher PSI concrete. Now, if I was putting a footer and building a wall on the perimeter of this slab, then the footer would be a 1 by 1 foot minimum, and I would have at least 2 runs of rebar in it just for the structural support. For this pour, we ended up using 16 yards of concrete that came out to $177.67 per yard. That's with upgrading to 3,000 PSI and adding the fiber to it. So 16 yards cost a total of $2,842.72. On the ticket that I have here, I actually ordered 19 yards, but 3 yards of that went to go finish a concrete pour for my neighbor. In addition to the price of the concrete, I also hired my concrete finishers to come pour and finish the concrete, and they have a minimum charge of $1,000, and this square footage was underneath their minimum, so they charged me the $1,000 minimum. Once the concrete is poured, it's really important to keep it hydrated for at least the first week, because it takes 28 days for concrete to fully cure. So if you keep the concrete wet while it's curing, it slows down the curing process, and the finished concrete is actually much stronger. So for the first week after they poured the concrete, I would regularly go out at least twice a day and hose down all of my concrete to keep it wet and slow down the curing process. After the first week of wetting the concrete and allowing it to slow down for the cure, it was time to go ahead and remove the forms, which I did this part by myself once again, and I build my forms with screws. So my first step is I'll go and remove all of the screws. Then I can take a sledgehammer and tap the boards to break it loose from the cured concrete. And then I can start removing the stakes and removing the boards till everything's accessible. After that, I'm going to use the skid steer to clean up all the concrete that flowed over to the outside of the form and get all of that excess material and debris cleaned up and out of the way. Once that's complete, it's time to get ready to install the sod. Whenever I'm installing sod, I like to make sure that there's some nutrient-rich material for the sod to sit on. That way the roots can take into it and get all the nutrients that it needs. I also like to have a material that will allow water to percolate freely underneath it and drain the area very well. So I'm going to have a very good slope going away from the house, and I'm also going to use my favorite material, which is river silt, to provide the drainage and the percolation, as well as having a high nutrient content to allow the grass to thrive. I got an 18-wheeler load of river silt delivered for $400, and then I used the skid steer to spread it in the area that I needed it, and then we used landscape rakes to aerate that soil before we started putting the Zoysia down. The river silt cost $400 to have it delivered, and the Zoysia cost $250 per pallet. I started out with just one pallet and then decided to go ahead and get another one, so I spent $500 on the Zoysia grass. Installing sod is a labor-intensive process. Luckily, we had the skid steer available to move the pallet of sod around to where we needed it, so we didn't have to commute the sod very far. My buddy Aaron, who is a landscaper, came and gave me a hand installing all the sod and make sure that we did it right and staggered all of our joints so that it would look very good once it started growing up. And then we also had our dogs on site for quality control, and I'm pretty sure they rolled on every single piece just to make sure that it was soft and level. The total price for materials and labor came out to $11,000, and here's the final result.